Good afternoon to all. Today we are going to discuss alcohols, phenols and ethers. Okay. So this is a scoring lesson in neat point of view. Okay. First we need to be thorough with the concept. Then we can easily answer the questions which are coming from this topic. Okay. So alcohols, phenols and ethers. Let us see how these compounds are formed. Okay. When we consider a hydrocarbon, for example, let us consider CH4. Okay. So when one of the hydrogen from this CH4, if it is getting replaced by OH group, then alcohols will be formed in this way. Simple thing. From the hydrocarbon, one of the hydrogen, if one of the hydrogen gets substituted by the OH group, alcohols will get produced. This is from the aliphatic system. From the aliphatic systems, we are getting alcohols. In the same way, when we consider an aromatic system, for example, benzene. Benzene, if you consider, this is an aromatic system. When one of the hydrogen from this, if it is getting substituted by OH group, okay, we will get phenols. This is nothing but phenols. In the same way, when we consider ethers, okay, how ethers are formed means when hydrogen from these hydrocarbons, if they are getting substituted by alkoxy or aryl oxy groups, then ethers will be formed. For example, the same CH4, if we consider, okay, if it is replaced with one of the hydrogen from this, if it is replaced by alkoxy group, OR, R indicates the alkyl group, OR means alkoxy group, then the product will be CH3OR. This is nothing but ether. Okay, or if aryl oxy groups can also get substituted in place of hydrogen. So this is how alcohols, phenols and ethers are formed. Phenols and ethers are formed. We know the general example, nothing but if you see the spirit or the wood spirit which we use for cleaning the furniture, it is made up of alcohol only. That is the alcohol which they were using in order to clean the wooden furniture is nothing but ethanol. Ethanol is used for cleaning wooden furniture. Okay. There are some other compounds which contain OH groups and we use them in our day-to-day life. For example, when we consider sugars also contain OH groups. Sugars contain OH groups, is that right or not? Or the cotton fabrics which we are using, okay, they are also made from the compounds containing OH groups only. So in this way, there are many compounds which are made of these OH groups. Okay, let us go into the topic. Okay, please note these things. Now let us see the classification. So based on the number of OH groups, okay, so we can classify these alcohols or phenols into different types. Okay. So, based on the number of OH groups, alcohols or phenols, they can be classified as mono, di, tri or polyhydric alcohols. Okay, for example, if you see CH3OH, this is a monohydric alcohol. Since a single OH group is there, we consider it as monohydric alcohol. In the same way, phenol, it also comes under monohydric alcohol. Okay, so dihydric alcohols means two OH groups will be present. So we call them as dihydric alcohols. This is one example. It is a dihydric alcohol. Trihydric alcohol means three OH groups will be present. Simple things only. trihydric alcohols. So if 3 OH groups are there, we call them as trihydric alcohols generally in this way. Okay, more than 3 means we generally call them as polyhydric alcohols. So based on the number of OH groups, we classify alcohols or phenols in this way. Okay, this is one type of classification. Again, if you see these monohydric alcohols, they are further classified based on the type of carbon the OH group gets attached. We will see that classification now. Okay. So the next classification, compounds containing sp3 hybridized carbon OH bond. Nothing but in this case OH group it gets attached to sp3 hybridized carbon. Okay. So for example, let us consider CH3 CH2 OH. Okay, in this case if you see OH group is attached to a carbon which is sp3 hybridized. This carbon is sp3 hybridized. Okay, again these compounds in which OH group gets attached to sp3 hybridized carbon, they are further classified into 3 types. They are nothing but primary, secondary, tertiary. Primary, secondary, tertiary. Let us see what is primary alcohol, what is secondary alcohol, what is tertiary alcohol. So the example which I have given, it is a primary alcohol. What is a primary alcohol? Nothing but if OH group is attached to a carbon and that carbon, if it gets attached to a single carbon, we call that as a primary alcohol. Primary alcohol means OH attached carbon should get attached to a single carbon. We call that as a primary alcohol. Simple thing. Next step. So okay, this is a primary alcohol. This is also a primary alcohol. Don't think that this carbon got attached to 2 other carbons. No, why it is a primary alcohol? Here you need to understand that the OH group attached carbon should get directly attached to a single carbon. Then only we can call it as a primary alcohol. This one. Okay. Secondary alcohol means what? If OH group attached carbon gets attached to 2 other carbons, we call it as secondary alcohol. For example, if you consider this. OH group is attached to this carbon and this carbon got attached to 2 other carbons. So we can consider this as a secondary alcohol. Okay. Next is nothing but tertiary alcohol. Tertiary alcohol means simple thing. If OH group attached carbon gets attached to 3 other carbons, we call it as a tertiary alcohol. Okay. So this is nothing but tertiary alcohol. You can observe here, this is the carbon to which OH group got attached and this carbon got attached to 3 other carbons. So it is nothing but tertiary alcohol. So all these carbons, OH attached carbons, these are nothing but sp3 hybridized carbons only. Remember that thing. sp3 hybridized carbons only. How to know that it is sp3 hybridized means see the number of sigma bonds formed by the carbon. Okay. If you see this carbon, it is forming 1 sigma bond with this carbon, 2 sigma bonds with these hydrogens and 1 sigma bond with these oxygen. So total 4 sigma bonds are formed by this carbon, by the carbon to which OH group is attached. That is why we are saying it as sp3. Okay. So this is one classification. You can just note down this. Now let us see allylic alcohols. I have already discussed about allylic alcohols allylic compounds I have already discussed in haloalkanes and haloarenes. Anyway, I will be revising, I will be telling about what is this allylic compound once again. So, allylic alcohols. Allylic alcohols are nothing but OH group attached carbon. If it gets attached to a double bonded system, we consider them as allylic alcohols. Simple thing. For example, this one. So it is an example for allylic alcohol. See, OH group, it got attached to this carbon and this carbon got attached to a double bonded system. Such type of alcohols we call them as allylic alcohols. Okay, OH group gets attached to a carbon and that carbon, if it gets attached to a double bonded system, we call them as allylic alcohols. So this is also sp3 hybridized only. Okay, again these allylic alcohols can be classified as primary, secondary and tertiary. For example, CH group double bond, CH, CH3, OH. If you see this compound, it is also an allylic alcohol. But here the OH group attached carbon got attached to two other carbons. That is why it comes under secondary allylic alcohol. If you see this compound, it comes under primary allylic alcohol. OH group attached carbon got attached to only one carbon. That is why primary allylic alcohol. Next, tertiary allylic alcohol means the OH group should get attached to three other carbons. Okay. In this way. So it is a tertiary allylic alcohol. Okay. OH group got attached to the carbon and this carbon got attached to three other carbons. Remember that this carbon got attached to the double bonded system. Okay. And two other carbons also it got attached. Total this carbon got attached to three carbons. That is why we are calling it as tertiary allylic alcohol. So this is one more classification, allylic alcohols. Please note down. The next classification is nothing but benzylic alcohol. Benzylic alcohols. Okay. In these alcohols also, OH, it gets attached to sp3 hybridized carbon only. But that carbon will get attached to an aromatic system. That is why we call them as benzylic alcohols. For example, this is a benzylic alcohol. Here if you see OH group, it got attached to this carbon and this carbon got attached to the aromatic system. So we call them as benzylic alcohols. Okay, these can also be classified as primary, secondary and tertiary. So this comes under primary benzylic alcohol. Secondary means simple thing, CH, CH3. This is nothing but secondary benzylic alcohol. Tertiary means this is nothing but tertiary benzylic alcohol. See, if you have understood about primary, secondary and tertiary alcohols, it will be easy to understand these things. Okay, benzylic alcohol means OH group gets attached to a carbon and that carbon will be sp3 hybridized and that carbon will get attached to the aromatic system directly. Then we call them as benzylic alcohols. They are again classified into primary, secondary and tertiary. It is based on the carbon to which the OH group got attached. If the carbon which got attached to the OH group, if it gets attached to a single carbon, primary. Two carbons, this one, secondary. Three carbons, 1, 2, 3, tertiary. So this is one classification. Okay, please take this. So now, till now we have seen the alcohols in which OH group got attached to sp3 hybridized carbon. Now the next classification is nothing but OH group will get attached to sp2 hybridized carbon. Okay. So there is one more classification based on the OH group attached to sp2 hybridized carbon. Let us see that. compounds containing sp2 hybridized carbon OH bond. sp2 hybridized carbon OH bond. Let us see about this classification. Okay, in this the first one is nothing but vinylic alcohols. Vinylic alcohols. Simple thing. Vinylic alcohols means OH group will be attached to the double bonded system directly, and the carbons in the double bonded system will generally be sp2 hybridized. Simple thing. Okay, CH2 double bond CH2H. This is nothing but vinylic alcohol. See the difference between allylic alcohol and vinylic alcohol. Allylic alcohol means, okay, OH group will not attach to the double bonded system directly. Vinylic alcohol means OH group, it will get attached to the double bonded system directly. And here if you see the OH group attached carbon, it will be sp2 hybridized. Okay, you can see the number of sigma bonds formed by this carbon. One sigma bond with this CH2, one sigma bond with this oxygen of OH, and one sigma bond with the hydrogen. Total 3 sigma bonds, that is why it is sp2 hybridized. So these are nothing but vinylic alcohols. Followed what I said? Okay, please note down. Next if you see phenols. In phenols also, okay, OH group will get attached to the carbon of the aromatic system. The carbon of aromatic system is generally sp2 hybridized. For example, if you consider this, okay, here OH group got attached to the carbon of this benzene, and this carbon it is sp2 hybridized. So we generally call this as phenol. Okay, so this is one classification. Now let us see about ethers. So this is about classification of alcohols and phenols. Now let us see about ethers. So I have already said to you how an ether is formed. When we are substituting hydrogen of hydrocarbon with alkoxy or aryl oxy groups, then ethers will be formed. Okay. The general formula will be ROR. So these are nothing but ethers. Okay. For example, CH3OCH3. This is an ether. Remember one thing, on either side of this oxygen, alkyl groups or aryl groups will be present. We generally call them as ethers. Okay, and these ethers are again classified as symmetrical ethers and unsymmetrical ethers. Okay, ethers are again classified into 2 types: symmetrical ethers and unsymmetrical or mixed ethers. Unsymmetrical or mixed ethers. Okay. So symmetrical ethers, simple thing. On either side of the oxygen, if the alkyl groups are same, then we call it as symmetrical ether, like methoxymethane or ethoxymethane. So if you observe this compound and this compound, on either side of this oxygen, similar alkyl groups are there. That is why we call these two as symmetrical ethers. Unsymmetrical ethers means different alkyl groups can be present on either side of the oxygen. Then we call them as unsymmetrical or mixed ethers. For example, C2H5OCH3. This is one example. Or CH3OC3H7. So these are some examples. So if you observe this, on either side of this, on this side CH3 is there, on this side propyl group is there. So different alkyl groups. So we call them as unsymmetrical or mixed ethers. Please note that. Now let us see about the nomenclature. How to name alcohols, phenols and ethers. So let us first see about alcohols. So we are discussing about name, nomenclature. Okay. So here in this we will see how to name alcohols. Okay. So common names, iPad names. First let us see how to write the common name to an alcohol. Okay. So first see how to write the common name. First we will write the name of the alkyl group and then we will add the word alcohol. For example CH3OH is there. Okay. How to give common name to this means first we need to write the name of the alkyl group. What is the alkyl group here? Methyl. Later we need to add the word alcohol. So it is nothing but methyl alcohol. In the same way C2H5OH. Okay, so alkyl group is nothing but methyl alcohol. Simple thing. Or CH3, CH2, CH2OH. Here the alkyl group is nothing but propyl. So we write it as propyl alcohol. This is how we give common name. Okay, first we will write the alkyl name followed by the word alcohol. Now we will see. Now let us see how to give iPad name to alcohols. iPad names. iPad names are derived from the parent name of the hydrocarbon. Okay. For example, if you consider this CH3OH, okay, it is from the compound CH4 one of the hydrogen got substituted by the OH. This is the parent hydrocarbon. What is the name of this? Methane. Okay. So when we are removing the letter E, okay, when we are removing the letter E and adding the letters OL, we will get the iPad name. So the iPad name of this CH3OH is nothing but methanol. Okay, so we need to remove the word E from the alkane and we need to add the letters OL. Then we will get the iPad name of that alcohol. Simple things. For example, you take this one C2H5OH. What will be the iPad name? Parent name will be ethane. So we need to remove the E and add OL. Ethanol. This is nothing but propanol. Okay. In the same way, if you consider let us consider one more compound. CH3, CH, OH, CH. So, what is the common name of this compound? This is nothing but isopropyl alcohol. Isopropyl alcohol. The reason is nothing but OH2 attached carbon got attached to 2 methyl. That is why we use the word iso. 3 carbons are there, isopropyl alcohol. Then what will be the iPad name of these? So we need to give numbering now. Okay, 1, 2, 3. At second carbon, OH group is there. So the iPad name will be propane 2. This is the iPad name. Okay, please note down. Let us see some other compounds. Let us see some other compounds. Let us see this compound. So what is the common name to this? This is nothing but isobutyl alcohol. So why I have used the word iso? Because this carbon, last but one, it got attached to 2 methyl groups. That is why this is an iso. And totally if you see, there are 4 carbons. That is why butyl. 4 means we use the word butanol, root word will be butyl. So isobutyl alcohol. So what will be its IPAC name? We need to give numbering in such a way that the OH group attached carbon should get the least number. So if you see, I will start the numbering from this side. 1, 2, 3. I cannot start from left to right because OH attached carbon will get third number. If I start numbering from 1 from left side to right side, this carbon will get 3. So our rule is nothing but when we give numbering, when we give IPAC name, okay, the functional group attached carbon should get the least number. So right to left is correct. So nothing but how to write the IPAC name of this. At second carbon there is methyl. So 2 methyl. Okay, 1, 2, 3. Longest chain contains 3 carbons. Propane, 2 or 2 propanol also we can write. So this is the IPAC. Okay. Next. If you see this compound, okay. So the common name of this will be tertiary butyl alcohol. Okay, why we are calling this as tertiary? Because OH group attached carbon got attached to 3 other carbons. That is why we call it as tertiary. Okay, since 4 carbons are there, tertiary butyl alcohol. Okay, right? Next, if you see what is the IPAC name of this compound. Okay, so here if you see 1, 2, 3. This is the way to give numbering. At second carbon there is methyl group and OH group. So 2 methyl propane 2 R. Okay, 2 methyl propane 2R. So here a small mistake, right? So this is not propane 2R, this is propanol only, because here OH group got attached to the first carbon. So this is a small mistake. Please make the correction. 2 methyl propane 1R. This is not 2R because OH attached carbon is first carbon. That is why propane 1R, or you can just write this as propanol. Okay. Next 2 important compounds I will say. Please remember the names of those compounds. CH2, OH. So if more than one OH group is present, okay, then we need to write the complete name of the hydrocarbon. In previous cases, you have seen removing the E from the hydrocarbon. Okay, if a single OH group is present, we need to do in that way. If more than one OH group is present, then E of the hydrocarbon will be retained. Okay, for example, if you see this, 2 OH groups are present now. What is the parent name of this? Ethane. Okay, so we are not going to remove this E because more than one OH group is present. That is the reason. Ethane 1, 2. Since 2 OH groups are there, di or OL. Ethane 1, 2 diol. Okay. In the same way, if you consider CH2 OH, CH OH, CH2 OH. Okay. If you see this, here also more than one OH group is present. Here the parent name will be propane. Okay. I will write the complete name. Okay, at first carbon, second carbon and third carbon. When I give numbering 1, 2, 3. Either way you can give. The numbering will be same. So propane 1, 2, 3 triol. Okay, tri why we are using? Because 3 similar OH groups are there. Tri. OH group, when we write IPAC name, we need to use OH. Propane 1, 2, 3 triol. The common name of these will be glycerol. Remember this thing. Glycerol. Okay. So please take these things. This is about nomenclature of alcohols. Now let us see about nomenclature of cyclic alcohols. Cyclic alcohols. Okay. So while giving the name to cyclic alcohols, we use the word cyclo as a prefix. Cyclo is used as a prefix. Okay. Okay. So it is a ring. Since it is a ring, or since it is a cyclic compound, we use the word cyclo as a reference. Cyclo. How many carbons are there in the ring? 6 carbons. Hex. Okay. Since OH group is there, hexanol. Simple thing. When compared with aliphatic ones and cyclic ones, the only difference is nothing but aliphatic means straight chain compounds. Cyclic compounds are nothing but ring compounds. So in order to indicate that these compounds are ring compounds, we use the word cyclo. That's all. The remaining thing will be same. So don't be confused with the benzene ring and the cyclohexane. In benzene, double bonds will be present. In cyclohexane, single bonds will be present between the carbons. This is cyclohexanol. This is nothing but cyclopentanol. Okay. So there is methyl group attached to the cyclopentane here. So we need to give numbering. 1. So like how we give name to the aliphatic alcohols, in the same way we need to give. So 2-methyl cyclopentanol. 2-methyl cyclopentanol. This is okay. Simple thing. Okay. So to name cyclic alcohols, we use the word cyclo as a prefix to the root word, and we write English there. So these are nothing but cyclic alcohols. Now let us see about phenols. How to name phenols or aromatic alcohols, we can see. Okay. Phenol, if you see, this is nothing but phenol. So this is the common name as well as the IPAC name. Okay, phenol, it is the common name as well as the IPAC name. Okay. So if CH3 group is present on the benzene ring along with OH group, then we call them as cresols. We call them as cresols. Cresols are nothing but along with the OH group, if CH3 group gets attached to the benzene ring, we call them as cresol. Okay. Both OH and CH3 are adjacent to each other. Okay, at 1 and 2 positions. That is why we call it as orthocresol. When you want to give IPAC name to this compound, so first we need to give preference to the carbon having the OH, because this is the functional group. This is not the functional group. It is just a substituent. Okay, 1, 2. Nothing but 2-methyl phenol. 2-methyl phenol. Next, in the same way, we consider if CH3 is at 3rd position, then metacresol will call us. And the IPAC name will be 3-methyl phenol. In the same way, simple reason. If CH3 is present at para position, then we call this as paracresol. Then the IPAC name of this will be 4-methyl phenol. Okay, please take this. Okay, next. If two OH groups get attached to the benzene ring, okay, and if they are at 1 and 2 position, then we call that as catechol. See this. If two OH groups are present on the benzene ring, and if they are adjacent to each other, nothing but at 1 and 2 position, if they are present, then we call that as catechol. What will be the IPAC name? Okay. IPAC name will be benzene 1,2 diol. Simple thing. This is the benzene ring. At first carbon and second carbon, two OH groups are there. That is why 1,2 diol. Benzene 1,2 diol. If OH groups are meta to each other, at 1 and 3 position. If OH groups are at 1 and 3 position. 1 and 3 position means we call it as meta position. Okay, 1, 2, 3. 1 and 3 position. So we call it as resorcinol. Resorcinol. Nothing but this is IPAC name will be benzene 1,3 diol. We write it this way. Next, if they are present opposite to each other, nothing but at 1 and 4 position. If OH groups are present at 1 and 4 position, then we call it as hydroquinone or quinol. Hydroquinone, or we can call it as quinol. This is the common name. IPAC name will be, you know, benzene 1,4 diol. This is the IPAC name. So this is about nomenclature of phenols. Please note down. Now let us see the nomenclature of ethers. Nomenclature of ethers. How to name ethers. Okay. Let me take an example to make you understand more clearly. CH3OC2H5. Okay. So here there are two alkyl groups, methyl group and ethyl group. Okay. So in common system, okay, we need to follow the alphabetical order in order to name ethers. Okay, we need to follow alphabetical order for the alkyl groups. For the alkyl groups, we need to follow the alphabetical order. Here you see there are two alkyl groups, methyl group and ethyl group. So in the alphabetical order, if you see, ethyl comes first. Ethyl group, it comes first. Okay. So how to write this name? Ethyl, methyl, and we use the word ether at the end. Okay. First we write the names of the alkyl groups based on the alphabetical order. At the end we use the word ether. Okay. In this ethyl, methyl, ether. If two alkyl groups are same, then we need to use prefixes like di, tri. Okay. In the, for example, CH3OCH3. If this is there, then we give the common name as dimethyl ether. So both methyl groups are same. That is why dimethyl ether. Simple. Okay. C6H5OCH. So on one side methyl group is there, on the other side phenyl group is there. Alphabetical order. M comes first and then P. Okay. So this is the common name will be methyl phenyl ether. This is the common. Okay. So this is how we give common names to the ethers. Next, how to give IPAC name. Okay. How to give IPAC name. Let us see. So here, while giving the IPAC name, we use the word alkoxy. We use the word alkoxy. And the second thing is nothing but those alkyl groups which are having more number of carbons, it is chosen as the parent hydrocarbon. For example, in this first one, ethyl methyl, in this ethyl group has more number of carbons. That is why, okay, the name of this compound will be methoxyethane. Methoxyethane. We can see clearly, since the methyl group is having less number of carbons when compared with ethyl groups, this is taken as the substituent, this is the parent. That is why methoxyethane. Here, methoxymethane, because both the groups contain the same number of carbons. Both the alkyl groups contain the same number of carbons. Methoxymethane. In case of this, okay, methyl group, phenyl group. CH3 group has less number of carbons. That is why methoxybenzene we write in this. So the common name of this, okay, there is one more common name. We can also call this as anisole. Remember this, anisole. Methoxybenzene is also known as anisole. Okay. OCH2CH3. Okay. So what is the impact name of these? These will be ethoxybenzene. Ethoxybenzene. Common name is also there for this. That is nothing but phenol. Phenol. This is the common. Remember these common names also. Okay. So this is something about the nomenclature of ethers. So by this I am winding up today's class. In today's class we have seen about the introduction of alcohols, phenols and ethers. We have seen the different classifications of alcohols, phenols and ethers, as well as about the nomenclature. In the next class we will be seeing the preparations of alcohols, phenols and ethers. Thank you all. Thank you very much.